So welcome everybody to this latest video on 162 Maths, and in this video we'll be continuing with the theme of sequences and focusing on geometric sequences. Now, a linear sequence is when numbers in a sequence either increase or decrease by the same number. So in the examples you can see on the screen, so we've got 4, 9, and we can see that these numbers are each in this particular sequence all increasing by 5. And likewise for the one that's underneath it, we can see that this sequence, the numbers are decreasing by a fixed number of -10. And so the fact that all of these numbers are both the same, so in terms of these numbers here, then that would represent that this is a linear sequence. So it's either going up or down by the same number. Now in a geometric sequence, which is highlighted there, there is a common ratio or common multiply between each of the numbers in the sequence. So here you can see that the difference between each of the numbers are not the same. So here we've got +2, here we've got +4, here we've got +8, and here we've got +16. Now it would be possible by noticing a pattern between these numbers what the next number is. So you think, right, well the difference is just doubling. So the next difference then is going to be +32, which would be 64. However, another way of looking at this is, rather than looking at what's being added or subtracted, is recognizing that each of these numbers are being multiplied by 2. So the term by term rule is that you are multiplying the previous number by 2. Now the difference between the numbers is not 2. What you need to do is the term by term rule, which is where this comes into play more than a linear sequence, is the term to term is starting with 2 multiply the previous term by 2. And likewise for the one that's underneath it here, we can see that the difference between the numbers is +6, then it becomes +16, and so forth. Actually +18 rather. There we go. So here you can see that again we're looking at this. However, looking at a common multiply to see what the actual multiplying difference is we are multiplying each of these numbers by 3. So in a sequence, if you have a list of numbers and you find that the difference between each of the numbers is not the same, then that would therefore represent, it's more likely to represent a geometric sequence where you're looking for a common multiplier. Now here, to find this common ratio, the rule of a geometric sequence, let's put a bracket there, it's just missed off. All you need to do is simply divide two consecutive terms together. So let me just highlight this for your notes. So to find what the common ratio is, so if you do find that numbers do not have the same difference between the two, to find what the actual multiplier is going to be, all we need to do is divide two consecutive numbers. Now it doesn't matter which two consecutive numbers you go for, but there you go. And also use common sense to help you decide which two numbers you need to divide by what. So for example here, we can see that the numbers are increasing. So I'm going to be multiplying by a number that's bigger than 1. So here I'm going to pick two consecutive numbers. Let's go for 24 divided by 8, which gives me 3. So that means that each of these are being multiplied by 3. Now if I picked, let's say 216 divided by 72, that also equals 3. So that proves the point. Now where you do need to be careful of is if, let's say, you picked the first term divided by the second term. So you had 8 divided by 24. Now that would give you a third, which would be 0.33 recurring. But if I multiplied to check, if I multiplied 8 by 0.3 recurring, then I definitely am not going to get 24. So I know that I've got it wrong. So I need to flip these two numbers round to make sure that I've got the same common ratio, or the correct common ratio to say. And it's worth just making a note of that if a sequence is going up, then, so let's just make a little note. So if a sequence is increasing, then the ratio will be greater than 1. If decreasing, the ratio will be less than 1. And that's definitely something that's worth paying attention in terms of common sense. And I always say that's do well in maths. It's about 65% knowledge, 35% common sense. So again, looking at number 2, if I want to find out what the common ratio is, I'm just going to pick two consecutive numbers. So let's just go for these two. So I've got 42 divided by 7, which is 6. And again, so to get from one term to the next, all I need to do is just multiply by 6. So let's have a look at some example questions. So in these example questions, all we're asked to do is to find out what the common ratio of these geometric sequences and write down the next two terms. So for this, I'm going to need my trusted calculator. So let's just have that on screen. Reset it. So first things first, looking at this, question 1, we want to find out what the common ratio is. I'm just going to call that R. So I'm going to pick two consecutive numbers. I'm going to go for 24 divided by 6. Again, it's an increasing sequence, so I'm expecting an answer that's bigger. For in terms of the answer to this is going to be greater than 1, which it is, so it's going to be equal to 4. So here I'm multiplying by 4. So to find the next term, all I then need to do is enter 384 multiplied by 4 equals, and it's 1536. So for this one it's going to be, so the common ratio is 4, and the next two terms are 1536, and the next term is going to be times by 4 equals 6144. There's my answer for question 1. For number 2, common ratio here, so again increasing, so I'm expecting an answer that's bigger than 1. So 10 divided by 2, again picking two consecutive terms, which is 5. So again, what I need to do is multiply each of these by 5. Now in some cases you might be able to work out what the common ratio is in your head, which is absolutely fine, but if you're ever unsure, like I said, just multiply, or I should say divide two consecutive terms together, make sure the latter term is being divided by the previous term. So again, multiplying by 5, so the next two terms, all I need to do is multiply 250 by 5. So 250 multiplied by 5, which you should know the answer is 1258, which it is. And then multiply that by 5, so again on my calculator, times 5 equals 6250. Again, this could appear on both the calculator and the non-calculator paper, just in case of just doing a bit more maths. On a calculator paper, it'd be worth less marks. On a non-calculator, it'd be worth a lot. Now here you can see with question 3 that my sequence is going down. So here I'm going to have the latter term, which is 700, divided by the previous term, which is 1400, and that gives me 0.5, which basically means that my common ratio is being halved. So the next two terms is going to be 350, so 350 multiplied by 0.5, which is basically halving it. So it's going to be 175. The next one is going to be 175 divided by, so times by 0.5, same as a half, and we get an answer of 87.5. And for the last one, let's go for purple. So here my common ratio again is decreasing, so I'm going to go for 48 divided by 120, and so calculate 48 divided by 120 equals 2/5. So to get from this number to this number, what I need to do is multiply by 2/5. So to work out the next two numbers, what I need to do is 7.68 times by multiplied by 2/5 equals, and we get 3072. And then for the next term, all I need to do is multiply that by 2/5. Again, I get an answer of 1.28. And there we go. There's my final answer for that. So you can see how you could end up with nasty numbers, but as long as your method is correct, then that is going to be absolutely fine. Now I will put some practice questions in a worksheet in the description below, along with their answers, so you can check your understandings and get some sort of practice of working with some exam style questions based on geometric sequences.